All right, hello, class. I know I have not been giving you much homework, but your homework tonight is actually going to be to, dun dun dun, you're going to complete the review. We're having an assessment on Friday. You've probably seen it here every day for like the past 2 weeks, and if you haven't, I've been saying it, and if you haven't heard it, here's a reminder. In 2 days, you're going to have an assessment, so complete the formative review. Tomorrow when you come to class, you will do the same thing. The great thing about tomorrow's lesson is tomorrow's day is we're back to the regular time, so you can have more time. It'll be at a slower pace, and it'll be really good because it'll be a good class time to review. We are not going to be doing pages 31 through 32 today because we already did that. We are going to be focusing on pages 34 through the end of the packet. 36. Just like that, we got to the end of this packet. All right. Homework, complete the review, 34 through 36. All right. Let's look at page 34 and let's go through some of these together. This is a good homework review. I would like you to, at some points, pause this to do it on your own. You need to test yourself. You shouldn't just, because the whole point of this, obviously Mr. Bergen and I are going to make sure that you are completing this. Mr. Bergen's going to make sure that you're writing this and you're doing it. But at this point, you should be doing these on your own. You should be able to listen a little bit if you need to and stop, pause it, and listen to the rest to see if you completed it correctly. All right, if you look at this first one, it's asking us to complete a piecewise function. And from a table, we really haven't done that a lot. But you should be able to start thinking about what do you notice about your table and the values in your table. What do you notice? So if you look at it and you notice, I notice that it repeats around this 2, 0. That means that's probably a vertex. And I see that it is going up by 3 on each side. On the other side, it's going down by 3. That tells me it's an absolute value function. All right, perfect. So that means for me, and I'll make this bigger. That means for me, I'm going to have a piecewise function. So I'm going to have 2 pieces. The vertex is 2, 0. So that's my vertex. My HK is 2, 0. My A value, it's not going up by 1. It's going up by 3. All right, so when I go to do my piecewise function, remember, I've got the f of x is equal to 2 pieces. Typically, for absolute value, it would just be y equals, my A value is positive 3, x minus 2 plus 0. But I don't need to put the plus 0, but plus 0, right? But I need to do this in 2 pieces. So I need to remember that the left piece, because this is going up. How do I know it's going up, Miss Colo? Because it's going up on this side, and it's going down on this side. So it's got to be going like this. So it's like a V. And it's 2, 0. That's my point. So it's 2, 0. So let's say this is 2, 0. And it's going up 3 over 1, right? So I need to, this is just me sketching it to try and visualize each piece. So the first piece is going to be decreasing this way. So if I think of it, it's decreasing in this direction. So my A value for my first piece should be negative 3. And then because I'm not using the absolute value function, then x minus, what's your vertex? 2 plus 0. I don't have to write the plus 0, but where is this? Where your x values are less than 2. So my x values are less than 2. It's to the right. Now the other side, when I look at the other side of this, look, what do you notice? It's going up. So what's that mean about your A value? If it's going up 3 every single time, your A value should be positive 3 for the right side. Because you basically split this into 2 pieces. You split this into this piece on the left that's here and this piece on the right. So my first piece that we just did, it's going down when I'm looking at it. And then the second piece is going up. All right, so that's the next piece is going up 3 over 1, and that has a vertex of 2 plus 0, but on what domain? Where your x values are greater than or equal to 2. Now, if you're saying to yourself, Ms. Kola, how do you know whether it's greater than or equal to? That piece honestly isn't as important for an absolute value function. One of these needs to be greater than or equal to. I mean, one of them needs to have the equal to sign. So whether it's the first one and not the second one, that's fine. Or the second one and not the first one, that's fine. Just make sure that it's there. Okay? Number 8, this is awesome. They just want us to write it as an absolute value equation. So if you want to pause this before I go into it, you can pause it and then unpause it to see how we do it. All right? So here my A value is it's going up 1 over 1, up 1 over 1. And that's all I really need to know. I don't need to know the fact that this is going down 1 because I'm not writing it in 2 pieces. I'm only writing this as an absolute value. It does not say piecewise, it says absolute value function. That looks like this. If I'm a good note taker and I can never remember what means, this absolute value function means I'm writing it in this way. Okay? All right. Well, what's your A value? I already said it's going up 1 over 1, so my A value is going to be equal to 1. Your H value is going to be equal to negative 5. That's going to be interesting when we go to do the equation, right? And your K value is equal to negative 4. Then I can write this. This is going to be y, or f of x, equals, my A value is 1, so I can write 1, but I don't have to. My absolute value symbol, x minus negative 5, and we know that turns to plus 5. Remember that was negative before? Maybe I should do it maybe I should write it like this so that you can tell that it was a negative sign there and we changed it to a plus sign. That is a plus sign. Absolute value and then minus 4. And that's it. We're done. All right, let's look at the next part. Number 9 says make a table of values. Be sure to include the vertex in the table. This is awesome. Vertex for me always goes in the middle. There really isn't a middle here, but I'll put it here for the sake of having a middle. My vertex here is positive 6, negative 8. 6, negative 8 is my vertex. 6, negative 8. Now this is absolute value, so it's going up by the same amount every single time. So I'm going to put 7, 8, 9 on this side, 5, and 4. So here, I'm going to make my pen a little thinner. My output was negative 8. Well, this has a value of 5. That means on the right side, it's going, if you can envision this graph, 6, negative 8, so it's somewhere down here. That's the vertex, and it's going up. It's going up 5 over 1. That's the next point. Up 5 over 1. Now, I'm not counting correctly, but just envisioning what that looks like. It's going up 5 over 1. So this needs to be going plus 5, plus 5, plus 5. Negative 8 plus 5, be careful, is negative 3. Plus 5 is positive 2. Plus 5 is positive 7. Now on the other side, I got to think about it's coming from this place. It should be mirroring, so it's easy to do it. You can either go back the opposite way, and it becomes that number minus negative 8, but you can just remember that it mirrors on both sides. So it's going to be negative 3 on this side. It's going to be positive 2 on that side. Another thing you can do is you could plug all of these values in. Plug these values in and solve. Now that takes a lot of time, right? The easiest thing to do is start by finding your H and your K and then figuring out where to go from there. All right, now the last one we have to graph. I want you to pause this, of course, and try and graph this on your own first. Okay, so hopefully you've graphed it. Hopefully you graphed it. Don't short yourself. It doesn't help you any. All right, my vertex is positive 6, 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Positive 6, 4. All right. Now, this is an absolute value function. How do I know? Because it has the same kind of slope. On the left side, how do you know it's left, Miss Colo? Because it says less than 6. So I'm talking about this side where x is less than 6. So where x is less than 6, my slope is going down 2 and over 3. Now, if you think about it, to go down 2 over 3, to come from this side, and it's going down 2 over 3, I'm going to have to go in the opposite direction. So I'm going to have to go up 2, back 3, up 2, back 3, up 2, back 3. Now, on the right side of this graph, how do you know right? Because it says greater than, and my numbers are greater than are on this side of my... I should have been doing this probably all along, showing that axis of symmetry, right? All right, so this is my right side. I'm going to be, this is easy because I'm going to the right. So I'm going up 2 over 3, up 2 over 3, up 2 over 3. I can't fit that on the graph. Nonetheless, I can draw my lines. And that is our absolute value function. All right, let's look at the bottom of this page. Let's look at the bottom of this page. When I look at the bottom of this page, it says to evaluate this. So this is kind of like a montage, just a mix of all of the problems that we've done. But all I'm doing, honestly, is just plugging in all of the values that I have. So when I look at number 11, I would basically just plug this in. That's all they want us to do. If I plug in 4 here, what's my outcome? -4. Okay, I'm going to ask that you pause it at this moment, and then when you come back, I'll give you the answers for all of them. All right, number 12, if I plug in -7 here, well, it's already negative, and I plug in -7, I get +7. Here, if I plug in 0, we know anything times 0 is 0. Here, if I'm looking for this is the absolute value function or symbol, plug that in, I'm going to get +25. Here, if I plug -25 in, and there's a negative on the outside, so it's a negative, and then I plug in -25, that's going to be equal to +25. Be careful here. There is a negative and another negative, and they want you to plug in -2. All right, this becomes positive. -1 times +2 becomes -2. Be careful with that one. It's 1, 2, 3 negatives. Think of it that way. 1, 2, 3 negatives makes it a negative, odd number of negative. Here we're going to have an absolute value. Now you should know the absolute value is on the outside. There's nothing outside of it, right? So it doesn't matter what goes in these two, in between these two symbols, what should come out should always be positive. So even if I have 1, 2, 3 negative signs, this is going to end up being the absolute value of -6, because a negative times a negative is a positive, then a positive times that negative is negative, so I end up with -6. But I still have to take the absolute value of it, so it should be 6. So hopefully you did that correct. Same here, I have 2 negatives, and I'm plugging in this positive, so positive times negative, negative, negative times negative, positive, but the absolute value of any number, positive or negative, should be just 8. Next, number 19. This is an R. It's kind of funky. I was like, what is that letter? All right. Negative times a negative is positive. Positive times a negative is negative. So be careful. I've got this negative sign on the outside of my absolute value symbol. So this looks like this. Negative, absolute value of negative, negative, and then I'm still plugging in another -9, absolute value. This becomes positive. Positive times negative becomes still negative. Absolute value of it of negative. Now, I have to take the absolute value, breathe, just breathe. The absolute value of this -9 becomes 9, right? So this piece here becomes 9, but I still have the negative on the outside, so this actually becomes -9. This negative on the outside of it basically negates this entire absolute value. It like, yeah, you could take the absolute value of any number, but if I put a negative sign on the outside, my answer is going to be negative. All right. Hopefully you did that well. You did, or at least now you understood that. Let's look at number, oh, this is page 20, I'm lying, page 35, page 35. Now we're looking at, this is just kind of like an overview. So now we're looking at squares and square roots and just talking about the domain and the range of things. This page, actually what I'd like you to do, I'm going to kind of hijack things. We've kind of already talked about the domain and range of squares and square roots, so to speak. For instance, if I have numbers like 0, 1, 2, 3, 4, 5, 6, and I square these numbers 1, 4, 9, 16, 25, 36, then I try and take the square root. I can take the square root of that number and that number, but I cannot take the square root of 2 without my calculator, or 3, but I can do 4, or 5, or 6. Essentially, what ends up happening is I see that here, I can see that they're all the same, right? Here, I can see the relationship. When I take the square root of 4, I get 2. When I square 4, I get 16. Let's do another number that I can take the square root of it and I can also square it. The next number that I can take the square root of would be 9, and I can square it. So let's take a look at that. 9 squared is 81. When I take the square root, I get 3. You will notice that 4 to the second power is 16, right? 9 to the second power ends up giving you 81. But essentially we want to see that eventually all of my domain for this should be all real numbers, with the exception of taking the square root. I cannot take the square root of a negative number. This was honestly just to be an exploration of square roots and squares. It's not super imperative. So at this point, what I want you to do is start to begin to work on your review, which incorporates everything we've done up to this point. Okay, so that's what I'd like you to complete. All right. If you have any questions, please ask Mr. Bergen.